Hello 8th grade physics. Today we're going to learn about Ohm's law in series circuits and parallel circuits. If you don't know yet what Ohm's law is, just look back to the video previously shown covering the relationship between voltage, current, and resistance, where current is directly proportional to voltage and inversely proportional to the resistance. So watch that first if you have not yet already. So let's talk about applying Ohm's law in a series circuit. Here I've got a series circuit where current flows out of the positive terminal through each resistor component and then back into the negative terminal. So really there's only one loop for the current to travel through. So because there's only one loop, this is called a series circuit. Now in a series circuit, if we wanted to measure the current across one of these resistors, let's call it R1, the current would go from the positive through each resistor back into the negative. Well, the same thing would be the case for the second resistor and actually for the third resistor. So the current takes the same path across each resistor. So the current, we can say, is the same for all parts of the circuit. So we can represent that with the total current being equal to the current across the first resistor, second resistor, third resistor, so on and so forth. Okay. Now the voltage, however, acts a little bit differently. The voltage, you need to think of it in terms of energy. So the voltage will actually add linearly. So the total voltage in the circuit, which is determined by the battery, is going to be determined by adding the voltage across each resistor. So there's 1, 2, 3 resistors in this circuit. Again, it could go on forever. So let's talk about what it means for the voltage to add linearly. So to do that, I want to utilize this analogy. So as current passes through a circuit, the voltage will decrease along the path that it takes whenever it runs into a new circuit element. So essentially, if we go back to the circuit, the voltage will be greatest at the first resistor, it'll be a little bit less at the second resistor, and then even less at the last resistor. Now, this is the case because we can compare that to the water drum analogy to the left here. So the closer you are to the battery, which is going to be essentially the bottom of this drum, the stronger your jet is going to be, or the stronger the voltage, and vice versa. The further away you are from the battery or the further down the circuit you are, the weaker the pressure, which means the less voltage. So if you add, though, all of these different pressures or voltages together, you'll get the total pressure that is in the drum or the total voltage in the circuit. So that's what we're talking about when we say that the total voltage adds linearly. Coincidentally, the total resistance in the circuit also adds linearly. So that means that the resistance across each resistor will be added together to give you the total resistance. Now you can utilize all three of these values to calculate the total current, which is equal to the total voltage over the total resistance. Now you may need to calculate voltage independently along with the resistance independently in order to calculate the total current independently. And we're going to talk about how to do that here shortly. So to kind of summarize here, in a series circuit where there's only one loop, the current moves through all the elements, okay? And the more light bulbs you have, the less bright the light bulbs will be because the resistance will increase as you add more resistors. The current is the same for all the light bulbs because it has only one loop, and then the voltage is different in each component. So let's apply Ohm's law in a series circuit and see what that looks like for each component. So first thing we want to talk about is the fact that the current is the same at all components. So if the current is the same at all components, then the current in the battery will be equal to the current across each resistor. Second thing we want to talk about is that the equivalent resistance, or you can think of it as the total resistance, will add linearly. So the total resistance you can calculate just by adding all the resistor values together. And finally, the voltage at each component will be equal to the sum of all of the voltages. The voltage of the battery will be equal to the sum of all the voltages in the circuit. And to calculate the voltage at each component, we really just need to multiply the current by the resistance at that point. So let's talk about how to apply this in this scenario. So we're going to first start with the total resistance. Now my total resistance will be equal to the sum of all of my resistors in this circuit. So that will be 17 plus 12 plus 11, which is, I think, 40 ohms. So that's what's going to go in this equivalent resistance box, 40 ohms. Now to calculate the total current, I need the total voltage and the total resistance. Do I have the total voltage? Yes, I do. And that comes from the battery. So that's 60 volts. And we just calculated the total or equivalent resistance, which is 40 ohms. So my current is 60 divided by 40, which becomes 1.5 amps. And since this is a series circuit, the current that is in the entire circuit of 1.5 amps will be the current across each resistor. Boom, 1.5, 1.5, and 1.5. Now to calculate the voltage at each resistor, let's utilize this relationship for Ohm's law. And it's really just going to be the voltage at 1 equals the current, which is 1.5 amps, times the resistance of 17 ohms. And it's going to be the same thing for the second resistor. Instead, we're going to use the 12 ohms that the resistor has. Same current, 1.5 amps, and the resistance is 11 ohms for this last value. So we can calculate all of these values. Let's start with the first voltage, 1.5 times 17. We get 25.5 volts. The next one, we're going to do 1.5 times 12, which is going to give us 18 volts. And lastly, we have 1.5 times 11. 1.5 times 11, which gives us 16.5 volts. Good. Now notice, if you actually add all of these voltages together, let's add 25.5 and 18 to 16.5, we get 60 volts, which actually matches the total voltage of the battery. So that's a way to check our work, to make sure that all of these added together in a series circuit will equal the total voltage. And this truly is just how you would apply Ohm's law in a series circuit to calculate all of the different voltages, currents, and resistances.